Today we'll start learning the linear regression concept. First we start with the theoretical part and then we gonna run our model. The next video will be to run our model. It's part of supervised machine learning. If you know what is the supervised, back to the previous video where I described what is the supervised machine learning and supervised and a neural network. So we have two types of statistics. Descriptive statistics, where this is for organizing, displaying, and describing data by using table, graph, and summary measures. This is where we use the mean, median, mode, standard deviation. And we have inferential statistics where we use the sample data to predict your new y from the sample data. And there is what we use the linear regression, logistic regression, and all the model. So this is what we are now is type of inferential statistics. So all this linear regression, logistic regression, all the model is part of inferential statistics. So what is the linear regression? We use it to predict predictive analysis. So the model is give you the relationship between dependent variables, the target y is called dependent, and independent variables, the predictors x. Is used worldwide, finance, economic, psychology to understand and predict the behavior. It's used in oil and gas everywhere. So you have two types of linear regression, simple and multiple. The simple linear regression, you have one y and we have one x. Multiple linear regression, we have one y and multiple x, and multiple one dependent, more and two independent. So what is the linear regression? This is the equation of linear regression. Y equal to beta 0 plus x1 beta 1 x. So y is where you put your y, and this x where you put your data x. This is your dependent and this is your independent variable. Beta 0, this red line when intersect with y is called beta 0. And the one that gives you this slope between your x and y, this is where beta 1 x, this is the slope and this is the intersect. So when you run your model, the model linear regression, you will find the best beta 0 and beta 1 that fit your model. He will find the best one. So this is your, and he will give you a new y, is called y hat, the predicted y, and depending on this predicted y, he will give you the predicted beta 0 and beta 1 to fit your model. So beta 0 and beta 1 is called the coefficient or the parameters. For example, if you have, this is for simple linear regressions, you have only one y and one x. For multiple, we'll come to the multiple next to that. So if you have, you need to check if you have your y is your price, and you have your x is represent the number. So you have room number and you have your price. So you need to predict a new price based on your data. So you give him your y, you give him your x, and you need to check, and you need to predict a new price. The predicted price is where beta 0 plus beta 0 and beta 1, this is the coefficient. The model will give you the estimated value based on your parameters, the y and x. So after you run your model equation, so you have this figure where you see this one, the red, the blue one is where this is represent your model, the predicted value, the predicted model, and where the red is where this is where your y and x. So the difference between your predicted model, the blue line, and the red dot, the true y, is called the residual. Residual y minus y hat. Y hat is your predicted y, is the model, the blue line. The blue line represents the beta 0 and beta 1 multiplied by x, the whole model. And y, this is represented by the dot point. This dot point is y. Is your true value, your true y, that you inserted your y. The difference between your y, the true y, and the predicted y is called the residual, or is called the error. So because we have upper data and lower data, so we have minus, we have plus positive values, and we have minus negative values. So to just avoid the negative values, they add residual sum of squares, RSS, residual sum of squares. So e1 square, e2 square until the en square, until the number of sample. If you have the 1,000 number of sample to the 1,000 number of sample, he will collect all the residuals and collect them all and then square them just to avoid the minus sign. And we have RSS, this the equation. If you know where this equation came from, because you have this is there, you have your model y beta 0 beta 1 x, and you have this is the epsilon y minus y hat. So y hat equal to this equation, you just would drag this one in here. So y minus beta 0 and the 1 minus enter to this equation. He will change the from positive to minus sign, and then you have this equation. And this is what you see in here, RSS residual sum of square y minus beta 0 beta 1 x and etc. So this is the residual sum of square. He will tell you how far your prediction model from your true value, how far this prediction model from your true value. If it's so far, that means your model is not fit for linear regression. If it's so close, that means your model is fit. So this is the purpose of residual and sum of square. So if you need to find the best, so the goal is to find the best beta 0 and beta 1 that minimize the RSS اللي هو the RSS residual sum of square. And if you need to find the beta 0 and the beta 1 that minimize the RSS, and the RSS, the difference between the true and the predicted. If you minimize, that make the difference between the true and the predicted is very low. That means your model is fit. So there is some calculus to show you how to minimize. So if you need to find beta 1 and beta 0 instead, the model will give you estimated value. But if you need to find them mathematically and to find the best fitting line, so go calculate them manually. So beta 1, this is x minus x. This is why I told you about the descriptive statistics, because x is x mean and y is y mean, and here is x is for equation. So you don't need to worry about that, and the model will give you directly when you run the code. But this is just for explanation. You don't need to remember any one of them. And beta 0 y minus beta 1 x. This x mean. That's why I talked about the mean standard deviation. When you run your model, you will have your residual, a difference between true and you have the coefficient, you have the intercept. This is where your y, and this is where your room is your the intercept is beta 0, and this is room number is for your beta 1. Beta 0 intercept, beta room number is beta 1. So what does that mean, the estimate value? That means in every 1 unit change your intercept, your beta 0, it will change minus 34.6, and your beta 1, in every 1 unit change your room number will change 9.0997. And we'll come to this one, standard error, t-value, p-value. This is when you run your equation in the R programming language, you will face this. You will see this one. So you have to understand what is this one. First you have the residual. This is the difference mid, medium, and the max, the difference between the true value and the predicted value. And what is the coefficient? This is where your beta 0, and this is where your beta 1. This is the estimate value. Now we will describe what is the standard error, what is the t-value, what is the p-value, what is the significant convolution, what is the residual standard error. So when you run this equation, you will understand them. Okay, we assume that the true relationship between. So now we assume the true relationship between the x and y is called y equal to f of x plus a. And y is equal to f of x. This is beta 0 plus beta 1 x plus the epsilon e. So why we add this e is called the error term. This error term for capture the random noise or things that line cannot explain. So this is the model, linear regression model, and this is the population linear regression line. The red line, you cannot see this one. This is to capture the random things that you do not understand with your data. For example, so if we have to support your predicted student score based on hours of studies. So if if a student studies 2 hours, so if it's studied 2 hours, 2 multiplied by 5, this is 10, plus 20, this is 30. So based on the prediction, if he studied 2 hours, he should get 30. But in real life, when he go to exam, maybe he didn't sleep well. Maybe the IQ test, maybe he was healthy, maybe he was stressed. He will not get exactly 30. He will get to 28 or 32, 40. So that's why there is another factor you cannot see. You cannot predict what's going to happen. And that's why they came with epsilon, the error term, just to make the things as close to the real life, because there is something you cannot understand from your data. So when you are talking about the price of the house and the room number, there is another factor you cannot understand with your data. This is factor like what is beside the area, what is something that you cannot understand. That's why they came with the epsilon, to capture the random things or things that is cannot explain. You will not see this the population line, so that's why they came with epsilon. Just okay, and I need to differentiate between two things. What is the error term? What is the residual? So error term epsilon is the difference between the true data generated process and the regression line. Don't mix between the error term. This is true regression line, and the difference between the true regression line and this is the regression line is where the epsilon, and this one cannot calculate it. We never actually absorb the true E. But the residuals that we talked about earlier, the rest of the residuals, is the difference between the Y and Y hat, the difference between the true value and the predicted value, and we can calculate it from the equation. So this is sample level and this is population level. Don't mix between them. And now we came to the standard error. As I told you, when you see, we came to the standard error. You have to understand the second is the standard error. So standard error is used for uncertainty, is you measure the uncertainty in your estimated coefficient for a regression model. What does that mean? The uncertainty, the variability in your estimate. So this is the equation where you count the standard error, the uncertainty for your beta 0 and beta 1. So beta 0 equal to standard error for beta 0 and standard error for beta 1. This is the equation. As I told you, you don't need to worry about them. Just I'm going to explain to them, but you don't need to worry. They will give you the direct when you run the model. It's just for explanation. So sigma 2 is not known, but we can estimate from the data. This estimate is known as the residual standard error, RSA. So because we don't know what is the sigma 2, we will compensate any value that equal to sigma 2 with RSA, residual standard error, that is equal RSS, residual standard square, divided by n number of sample minus 2. So instead any sigma square, we came with RSA in the equation, and the goal is to calculate the standard error. And what is the standard error? Why we calculate the standard error? To find the uncertainty. What is the uncertainty that we are looking for? When you calculate the beta 1, when you run your model, it will give you the estimate value for beta 1 and beta 0 to fit your model. But if you depend on certain value, but if you change, or if you add more data, or you change your data set, he will give you another different beta 0 and beta 1. So whenever you change the data set, he will give you different beta 0 and beta 1. And the goal is to tell you how much these estimated with fluctuated across different sample. So if you choose different samples and beta 0 and beta 1 changing, beta 0 and beta 1 changing, different sample, beta 1 changing. The goal is to find is where your beta 1 and beta 0 is not changing. If it's not changing, that means you reach to the point that there is not too much difference. You reach the point the beta 0 and beta 1 cannot change, and that means this is the best, or this is the perfect beta 1 and beta 0 that fit your model. Cannot change, so you cannot do any more changing on that. This is your best one. And this is approximately, there is approximately 95 chains that the true interval, and this is the interval, will contain the true value of B1. So when you calculate the standard error, so beta 1 minus 2 multiply the standard error, beta 1 plus 2 multiplied by the standard error, this is the will contain the true value. You're looking for the true value for beta 1, that give you the slope, and if you find the true value within this interval, and that means this is the true value, this is the value for beta 1 that is not changing anymore, and this is the best one for my model. And what does that mean? We'll disclaim it here. So what is the purpose of the standard error? To measure the uncertainty, variability in your estimated coefficient range of model. And what does that equation mean? So this equation, this interval, I'm gonna explain it to you in here, so it will be more. So as example, imagine that estimated that we have a slope beta 1 equal to 0.5. Okay. So beta 1 equal, this is the our interval, is beta 1 plus minus 2 multiplied by the standard error. Same, this one is interval. You have minus and you have a plus. It's the same. This is the interval that you're looking for. So if beta 1 equal to 0.5 and the standard error equal to 0.1, so 0.1 multiplied by 2 plus minus 0.3, so you get this interval. So the 90 chains, the 95 chains that this value, the true value within this interval, so based on your sample, the true slope is likely somewhere between 0.3 or 0.7, the true slope between this value. Any slope in this range is plausible, reasonable, consistent with your data. Any slope is outside this range, 1.5 or 2 are not plausible because the true slope were far away. I hope this makes sense. So now we go to the hypothetical tests. We need to, so this is for standard error. This is, you will see when you run your model, this is the standard error here. So you understand the uncertainty between your beta. This is for your beta 0 and this is for your beta 1. This is beta 0, this is beta 1, this is from the model. But if you need to find the best one that fit, you have to calculate them from the equation that we talk about. If you need to find them, you have to calculate the standard error for beta 0 and beta 1, and then okay. So now it's time for what is the t-value in your model. So imagine this scenario, we come to the hypothetical test. And when you run your model, so we have beta 0 and beta 1 equal, and beta 1 multiplied by x. Beta 1 multiplied by x, if beta 1 equal to 0, that means there is no relationship. So we need to find h0, there is no relationship between x and y. So we need to find if there is a relationship between x and y, or if there is no relationship between x and y. If there is no relationship between x and y, that means beta 1 is 0, that means there is no relationship between x and y. That means your input x is there have no relationship with y. But we need to disprove that. And to disprove that, we go to calculate the t statistics. So t statistic, we need to disprove the beta 1 is not equal to 0. So t beta 1 minus 0 divided by the standard error. and that's why you will see the t-value when you run your code. You will see the t-value. That's what we're looking for. And after that you will see the p probability value. From the t-value we'll calculate the probability. We also compute the probability of observing any value equal to t or large. We call this probability the p-value. A small p-value means there is a significant with your data, and large p-value, that means your is not significant. And you will see that when you run your model. So t-value, we need to prove that the beta 0 is not equal to, and this is the hypothetical test. We need to see the test value, if the beta 1 equal to 0 or not. If beta 1 equal to 0, that means your data that insert, they have no relationship. That's why you have to go for t-test to test that if you have large beta, if you have large t, that means there is a relationship between them. If you have a small, that means, so if you have large beta, that means you have large t. If you have large t, that means you have large beta. Large beta, that means there is a relationship between. If you have a small beta, and we'll describe that in a minute. So if you have a standard error, you estimate precise, more reliable. Dividing by, okay. If the standard error is small, okay, your estimate is precise, more reliable. Of course, if the standard error, the difference. If the standard error is large, your estimate is very uncertain, less reliable. That's why SA is directly used in the statistic for testing significant. So because this one have direct have an relationship, this one, so if you have big beta 1, that means the t is big. If you have the small standard error, that means you have large t, and you're more reliable, because if it's this large, that means the beta is large, that means not equal to 0. And this is what t-value. If the slope is large, the t is large. If you receive large value of t when you run your model, that means your beta 1 is large. Strong evidence against h0. And what does that mean? Strong h0, that means your hypothetical test for beta 1 equal to 0 is rejected. H0 mean the H0 mean that your beta 1 equal to 0, and we need to disprove that. So H0, that mean is against. If you have large values of t, that mean you have large value of beta 0 and beta 1, and this is that mean is not equal to 0. If a small value of t, that means you have a small value of beta 1, data is contained with a slope, that means the beta 1 equal to 0. So you have to check if your beta is a t large value, that means beta 1 is okay. If it's low, that means small, that means your beta 1 equal to 0, and we need to disprove that. That means there is no relationship between your x and y. So you have to change your x, not changing your x value, not your boyfriend. And after that you will see, after you finish the t value, you have to go for p, probability of t. It is bigger than this is the calculus of t. So they change the t statistic into the probability. So if the p value is less than or 0.05, reject 0, that means the slope is significant. Reject h0, that means reject the probability of h0, the beta 1 equal to 0. So reject it. Slope is significant. If beta 0 more than or equal to 0.05, that means fail to reject the h0, that means slope might be 0, not significant. And you will see that also in when you see the p-value. If it's very small, the p-value, that means this is significant. It is less than or bigger than. If it's less than 0.05, that means significant. More than 0.05, that means okay. And we have quality to fit RSA, so residual standard error. And the quality of linear regression fits is typically assessed using the two related quantity is the residual standard error and the R square. So this is to check if your linear regression is to fit, typically assessed using the two. So if it's the fit for the linear regression is fit for your data or not, you have to consider the residual standard error and the R statistics. So RSA is equal to 1 dividing number of sample residual standard error, and then so RSA is average amount that the response will deviate from the true regression line. So this is the average amount that is response will deviate from the true regression line. Is also considered as a measurable of lack of fit the model of the data. So RSA will tell you if your model is fit to your data or not. So residual, you will see when you run your model, you will see residual standard error and you will see the value. So if you have a value is high value, that means RSA is fit to your model. And equality of fit to check your model is fit or not, you have residual standard error and you have the R square. So R square is total sum of squares minus residual sum of squares divided by the total sum of squares, and you will see your R square in here. Adjusted R square and multiple R square. So if your R square was close to 1, that means your model is fit. Your training predictor is so fit, your model is fit. If it's close to 0, that means R square close to 0, that means your model is not fit. If it's close to 1, that means your model is so fit for your data. And this is for to check your fitting data. And also we have, so for multiple linear regression is the principle is the same, nothing changed, just we have more than one input value. So you have more independent variables, more x. So you have one y, but you have beta 0 is the same. So beta 1 multiplied by x1, beta 0 multiplied by x2 until the, if you have 10, 15, if you have 3, 4, whatever the independent variables, the x you have, is the same principles. And instead of simple linear regression, multiple linear regression, you will see intercept. This is the beta 0, and you will see all the independent variables. This is all the x that you insert to calculate your predicted y. This is for x, this is all your x. So depend on how much x you have, independent variables, you will see it like that. Okay, and this is the significant code that is related to p-value we talk about. You see, if we have that mean 3 stars, that mean this code is significant. So significant code 0, that mean 1, 2, 3, this is so significant. If you have that mean is equal to 0, this is 0 point less than 0 0.1, 3, 0 0.1, so 0 0.05 and 0 0.1 and 1. So if you have a 3 star, that means this is so significant, this is so significant. This is 1, that mean is that mean the value is 0.05 because we said it is less than 0.05. It is less than 0.05, that mean it is highly significant. From significant, highly significant. If is bigger than or equal to 0.5, like 0.1 or 1, that means this variable have no relationship with the y, have not and is not significant relationship. So you have to check the p-value. If you have 3 stars, that means highly significant, highly significant, highly significant. 1 star, that means the value is 0.05. That means just 0.05. We said if it's less than 0.05, significant and highly significant. Bigger than 0.05, like 0.01, 1, does that mean this relationship is very low? This relationship for this x is have very low relationship with y, and you have to check. And this is the residual standard error, we'll talk about it. and this is the adjusted R square. How you calculate the R square? We have F statistics left. So for F statistics is to in regression is the test statistic that check whether your regression model provide a better fit to the data than a model with no predictors. So F statistic to check same if your model regression model provides a better fit to the data than, and this is the equation. This is total square minus the residual sum of square, and this is number of n is number of predictors, and p is number of predictors, and n is number of sample. And what is the F statistics? You will see this one, F statistics. So if the F statistics was high, that means your model is best in predict the value. If the F statistics is low, that means your model is not good for predicting. So if number of variables is large, there is very high chance that one of the B is wrongly classified. So a large F means your regression model explain much more variation in the outcome than just random noise. Small f, close to 1, means your model isn't doing better than chance. So if statistics, it will tell you how model is fit to the data. So if it's low, small f, that means your model is not fit for your data. So f have relationship with the p-value. He will check from the p-value. You can see this one have, so he will calculate this one significant, depend on this p-value, he will give you that f statistics. Like if you have more significance of your model, you will have high f. If you have low p-value, that means you will see low f, and this is the band that means your model is fit for your data or not. It's depend on, you can check if the p-value from here, you can check the f. So all this you need to know about the linear regression concept, the theoretical part. The next video will start running our code and how we calculate all the things that we talk about in here. Thank you for watching. See you in the next video.